The two legs of a right triangle are measured as 5 meters and 12 meters, with a possible error in measurement of at most 0.2 centimeters in each. Use the differentials to estimate the maximum error in the calculated value of A, the area of the triangle, and B, the length of the hypotenuse. Okay, so what are our knowns? We know, let's say, the base will be the 5 meters, the height will equal 12 meters, and it says that the measurement of at most 0.2 centimeters in each. So we know that the maximum change in the height is going to be the same as the maximum change in the base, which is 0.2 centimeters, which we will convert to meters, which would be 0.002 meters. Okay, so for part A, we need to find the area of the triangle. So we know that the equation to find the area is going to be 1/2 times the base times the height. Now this is a function with two variables, so in order to take the derivative of that, we need to use the differential equation. So in that is the derivative of z is going to be the derivative of z with the partial derivative of z with respect to x times dx plus the partial derivative of z with respect to y times dy. So first we need to take so in order to do that, we need to use that to find dA, which is going to be the derivative of a with respect to b times the change in the base plus the derivative of a with respect to h times the derivative, the change in h. So the partial derivative of a with respect to the base is going to be 1/2 times the height, because we treat h as a constant, and times that by changing the base, plus the derivative of a with respect to h, which is going to be 1/2 times the base. We treat base as a constant, and then times that by dh. Okay. And then simplify that to 1/2 times the height times the change in the base plus base times change in the height. So now we have everything we need. We just need to plug in our variables. It's going to be 1/2. The height is 12 meters times the change in the base, which is 0.002, plus base, which is 5 meters, times, again, the same change, 0.002, and that will equal, what is it, 0.017 cubic meters, or if we want to convert it to meters, or centimeters, it'll be 1.7 cubic meters. So, centimeters. Right. And so what that is the maximum change in the area of the triangle with this maximum change, 0.002 meters. So if we actually draw it out, if this is the triangle, the right triangle, right? And the height is 12 meters, and the base is 5 meters. If this were to change at all, you would get bigger that much, or bigger by 0.002 meters. this would be the maximum change in the area overall. Okay, so now for part B, we want to find the length of the hypotenuse. This is going to be pretty similar. So we know that the equation for a triangle to find the length of each side, c squared equals a squared plus b squared, if c was the hypotenuse. We can change that to solve for c. It would be square root of a squared plus b squared. I just got to change our letters around to match with our variables, so that we'll say that big H is going to be our hypotenuse. This is going to equal the square root of the base squared plus the height squared. Okay, now again, this is a function with two variables, so we're going to again use our differential equation to solve it. So that's going to equal, so to find dh, it's going to equal the partial derivative of h with respect to b times db plus the derivative of h with respect to, the derivative of the hypotenuse with respect to the height times dh. Now the partial derivative of h with respect to the base is going to be ½ times base squared plus the height squared to the power of -1/2, and then times that by dB, and that's going to be plus, very similar, it's going to be 1/2 times, oh, skip something. Got times, that's on the inside, which is going to be 2b, and then times that by dB, plus 1/2 b squared plus h squared to the power of -1/2 times the root on the inside, which is going to be 2h, and times that by dh. So we can simplify that. It's going to be, actually first, we can cancel out these, the 1/2 there and the 2, 1/2 there and the 2, and simplify it a little bit easier. So that's going to equal b squared plus h squared to the power of -1/2 times b, the base, times dB plus height times dh. Okay, so now all we have to do is plug in our variables again. And that's going to be 5 squared plus 12 squared to the power of -1/2 times the base, which is 5, times 0.002, a change in the base, plus the height, which is 12, times change in the height, 0.002. And that is going to equal 17 over 6,500. And that's meters, which can, in a decimal, would be about 0.0026 meters. Or if you want to put it in centimeters, it would be 0.26 centimeters. So that is the maximum change in the hypotenuse with 0.002 meters as the maximum change in the height in the base.